Hello guys, welcome to Discrete Math, and today we're going to teach you many things about encryption and hash functions in the real world. Please enjoy. Before we continue with the main topic, let me ask you something very quickly. Did you know that in every second you run the risk of someone stealing your personal data over the internet? Theft of personal data happens constantly day by day. People who do this type of crime are known as hackers. Let me give you an example. Let's say you are chatting with a friend through a social network, for example, Facebook. For this case, it happens that one of your messages arrives with a very different text from what you sent at the beginning. This is when the hackers kicks in. But how did the hacker change the message? One way to do this is throughout the man-in-the-middle method. In computer science, this is an attack where the attacker secretly relays and possibly alters the communication between two parties who believe that they are directly communicating with each other. But how can we take care of our information from being stolen or even plagiarized? The power of encryption is where it comes from here. We will take several points first. We have one sender, one receiver, one channel, one text, and one key. So the main idea of encryption is the protection of personal data throughout technology. As you can see, encryption is concerned with encoding the text with an algorithm, also known as a key. In this way, the hacker is unable to steal the information from the sender and the receiver.
In addition, we're going to see what is MD5. MD5 is a message digest algorithm. It's a cryptographic hash function. A hash function takes a group of characters called a key and finds it to a value of a certain length called a hash value or hash. Instead of confirming that two sets of data is identical by comparing their raw data, we check by use checksum to make sure it's identical or not. The idea behind the algorithm is to take up a random data text or binary as an input and generate a fixed size hash value. Also, the input can be any size at any length while the output is always fixed. One good example of the MD5 is generate MD5 hash for the intended file on your server. Download the file on your PC. Generate MD5 hash again for the downloaded file. Compare these two hashes. If they match, file is downloaded perfectly. We're gonna see a new definition. In checksum, it's a error detection method. For example, you download the file from internet. If the checksum don't match the original download file, the data may have been altered or corrupted.
Once the idea and basis behind the MD5 had been explained, the following is to explain the basic requirements that it needs to complete the encryption of a text or a message. In cryptography, MD5 is a widely used cryptography hash function with a 128-bit hash value. As an internet standard, MD5 has been employed in a wide variety of security applications and is also commonly used to check the integrity of files. An MD5 hash is typically expressed as a 32-digit hexadecimal number. Now, in the MD5 we have the following structure. We have a message with a multiple of 512 minus 64 bit, which length is equal to n times 32. Then we'll be adding a padding that is multiple of 512, and finally, we'll be adding a 64-bit for the original message. Next, the message is going to be divided into blocks with a multiple of 512 divided with 32 bits. So what is happening here is that once we broke the 512-bit message into blocks, each block will perform a special operation of division. The following step is that each block that has been in this process will be passed throughout the buffer. This means that each block will have a fixed hash value. This process is also called as an AVDC buffer process, where the output shall be a 128-bit hash value. The following thing is to talk about the padding steps. In the first one, we have that the message is padded, so that its length in bits is equal to a mod of 444 mod in 521. padding is always performed, even if the length of the message is already passed in the same month. Padding is performed as follows. A single 1 bit is appended to the message, and then 0 bits are appended so that the leading bits of the padded message becomes congruent to the next month. At least 1 bit and at most 512 bits are appended in this method. For the second step, we have that a 64-bit representation of the length of the message is appended to the result of the first step. If the length of the message is greater than 2 to the power of 64, only the low-order 64 bits will be used. The resulting message, after padding with bits, has a length that is an exact multiple of 512 bits. The input message will have a length that is an exact multiple of 16 words, or 32 bits. So this is the second process. As you remember, the implementation process requires a buffer called ABCD buffer to give outputs of 128-bit hash value from the blocks of the original message. For this, we have to pass to the third step of padding. The third step requires an initialization for the buffer. A 4-word buffer, ABCD buffer, is used to compute the message digits. Each of A, B, C, and D is a 32-bit register for this method. Once we know that in each A, B, C, and D is a 32-bit register, we have to know that these registers are initialized to the following values in a hexadecimal low-order bytes first. In word A, we have the following values. In word B, we have these values. In word C, we have these ones. And the last one for D, we have these ones. For the following, we have the fourth step, which is the process message in a 16-word blocks. In this step, there will be 4 rounds. Each round will have 16 iterations, making a total of 64 iterations with the 4 rounds. For every round, we will have a special processor function that is called as a function. These functions have special system operations to help the buffer in its performing. For the first round, we have this function. For the second round, we have this function. The third one for this, and the last one, this function. Once we know these special processor functions, we have the following question. How the values are changing in every round? Each round has a special formula, which is this one. This formula is in charge to process and transform the information in each iteration that is made in the program. As you can see, we have the value a equal to b times a plus the function of f with b, c, and d. In this part, we are saying that values b, c, and d are going to be the values of x, y, and z from the original formula or process function. So we are just substituting. But what is mi? This is in charge to break the 512-bit message into blocks. In this part, the MI is going to give us the specific number of blocks we want to implement in the method. There is a limit of 16 blocks of 32 bits for each one. The following question is, what is TK? TK means that there are 64 constants, and for every round 16 constants are used. So for the first round, there will be 16 constants that are going to be applied in the formula. So what happens inside the buffer once the formula is applied is that the ABCD values will start to rotate from right to left or from left to right, one rotation for each round. At the end, the final rotation will be the output for the 128 bit. Once we know all this information, let me give you something. Here is a simple graph representation about what is going on inside of the MD5 algorithm. Remember that this is a simple graph. So we are just taking the main idea of the algorithm. Finally, this is one way of how you can protect your data throughout technology. There are more ways to do it and how to avoid hackers. Remember that your data is the most important thing you have today. I hope you liked the video and had a good idea of how encryption and hash functions works in real life. Have a good day.